This video will give examples of careers in precious metals using chemistry, both inorganic and organic, chemical engineering, metallurgical engineering, and others. Our previous hydrometallurgy videos introduced the various leaching and concentration processes as the first steps in precious metals extraction. Electrochemical reduction explained several ways to chemically precipitate the aqueous precious metal compounds back to metallic form. In simple terms, the precious metals were put into solution by stripping electrons to create precious metal ions, which then dissolve into the solution. The processes to turn these ions back into metallic form each transfer electrons back to complete the transformation. Electrochemical reduction uses chemical reactions to transfer electrons for recovering metals, while electrolytic reduction uses electrolysis, which employs an electric current to accomplish this. Electrolysis is generally employed when separating and purifying gold and silver from virtually all substrates. Electrolysis takes direct electric current through a solution to drive chemical reactions. Direct electric current is passed from one electrode, called a cathode, through an electrolyte, the solution, to another electrode, called an anode. This is all contained in what is termed a cell. These processes are controlled by the chemistry of the solution, physical dimensions and orientation of the electrodes and cell, as well as the electrical current flow. Electrowinning and electrorefining are both electrolytic processes used to extract metals from solution. Electrowinning is the electrodeposition process, which can be thought of as large-scale electroplating. In electrowinning, electrical current is passed from an inert anode through leach solutions from mining operations, for example. The metal is extracted as it gains electrons and is deposited onto the cathode. Electroplating deposits thin layers of metal from solution electrically, whereas electrowinning deposits much thicker layers which can be removed from the cathode. Electrorefining is a very important technology used to refine precious metals to their purest form. Whereas electrowinning takes metals from leach solutions, electrorefining starts with anodes made of low-grade or mixed alloy precious metals. The electrolytic process takes electrons away at the anode, which dissolves the positively charged metal ions into solution. These ions are then selectively plated out of solution by adding back the electrons at the cathode. Fine-tuned chemistry of solutions and electrical currents are utilized to separate or part precious metals from each other. An example of this is the process used to separate gold and silver from alloys. Doré bars produced at silver mines are semi-pure alloys of silver with small amounts of gold and other metals. These other metals precipitated out along with silver during the cementation process discussed in our last video. The gold-silver alloy metal is used as an anode, and the electrolysis draws the silver into solution as the silver is stripped of electrons and transformed into silver ions. The silver ions then take back electrons as they plate onto the adjacent cathodes. The result is pure silver depositing on the cathodes and a gold-rich material being left behind for further refining. The final processes in recycling and refining precious metals from electronic scrap use separate electrolytic cells for gold and silver. Flat plates have traditionally been used to keep the current flow even and controlled. Cylindrical cathodes are also being used in some advanced processes. Other innovations in precious metal parting include the use of metal grain in anode baskets to allow for higher speed and more controlled deposition. At the end of these processes, the result is a pure precious metal, whether it's gold, silver, platinum, palladium, rhodium, or one of the other platinum group metals. The purity expected at the end of these processes is at minimum 395, and for specific purposes, whether banking and trading, alloy or pharmaceutical manufacture, the purity level required may be as high as 5 nines plus. Pyrometallurgy will be presented in our next video. The International Precious Metals Institute promotes the education and advancement of precious metals technology and business. IPMI is an international association of companies committed to providing technical resources and educational materials, including a series of videos presenting examples of precious metal applications and a variety of interesting and rewarding career opportunities.